Oh, mine's up. Yeah, cool. Hey, so my name is Anthony Burchell. I am the builder of 3OV, a WordPress plugin for building 3D worlds in the editor natively. So like no embedding, just straight up building inside of the WordPress post editor. And through this app is how I've been exploring standardization of extensions through the glTF format. So this is just a quick like plug of the app. This is what the editor looks like. You got like your WordPress standard editor, but it uses this new React-based editor called like codenamed Gutenberg that has individual blocks that have JSON, and that JSON defines the properties that make up a block. So you could have like headings. Like a heading, what's important to that is just the text that's inside of it. So that's an attribute. And in the case of these 3D blocks that I'm making in 3OV, you can define things like the name and the personality of an AI agent in the world, NPC. And what's interesting about this has been a really good testing bed for standards that I want to exist in the future. So like NPCs in the future maybe could define things like name, personality, the default message, and like maybe we figure out these attributes that define an extension. Essentially, like this is each block I would consider like an extension node inside of a glTF file, but in this case it's using HTML to represent each block of data. So this has been how I've been testing OMI extensions and mirroring them, trying to come in line with them, but also import the files that have these extensions inside of them and automatically create these blocks based on it. And yeah, you could download this in the WP admin of WordPress or WordPress.org. There's a repo there. And this has kind of been my philosophy, or my like North Star in focusing on standards first in building my platform. I believe that a truly open metaverse will be powered by open source software and open communities such as this one gathering today. So I think there's going to be, I hope, many of these in the future. And I don't think there will be an open metaverse unless that exists. So yeah. And I'm also part of OMI Group. I'm one of the champions that helps kind of shepherd things along in the glTF extensions group. It's also at like a high level. I manage the website and all of those things. And this is our mission. We bolster the metaverse as an open and interoperable resource for anyone inspired by the collaborative efforts of the community. We spent a lot of time getting to those words. But they actually mean something, is what I mean by that. We scrutinize every piece of this because we were just like, what defines an open metaverse? Because the name of the group is Open Metaverse Interoperability Group. So we very much needed to align with that. And I think we did a good job. And I'm also part of the glTF Extensions Working Group, which is the work that I'm going to be talking about here. Our mission is that we aim to create an ecosystem of specifications and tooling for accessible creation and use of durable and portable 3D content. I really love that. But that's what kind of guides this group's work. And glTF extensions go through a life cycle where at stage one, it's typically like in some cases it's just been like in Discord and M3, just like chatting about, hey, we should have like a spawn point extension. And this stage one is where that kind of inception or that idea comes to life, and you build your first high level outline of what could go inside of a glTF file and be used to standardize around some kind of feature. So in the case of that one with the spawn point, it was literally like overnight, got onto ChatGPT, said generate me some JSON for this, and then made a proposal, and it totally went through and got to stage two, which stage two is where things start getting a little more serious and people start implementing it and putting it into their platforms and try it out. You know, like we make very basic 3JS scenes that implement the spec so that we can use it as a test bed and example so that people can get on board with the extensions. And I guess I should take a step back and say, like, why are we doing that? I think it's kind of obvious, though, especially if you're here in Hyperfy, being able to drop a file into a world and have it perform the exact same way in every world is extremely valuable for all of us and is crucial to the success of the open metaverse. If not, then we're going to be stuck in proprietary formats for giant megacorps, and kind of want to avoid that. So these extensions exist inside of the document and can do things like it can store binary data, like an audio file, which I'll get into in just a moment. And then it stores attributes that can go inside, or that could point to that audio file and do things with it. It's not restricted to audio, so we could be thinking about other binary things to put inside of glTF files in the future, but we're starting with this because this one makes the most sense, audio. So getting back onto the stages, the stage 3 is kind of where we build the tooling around it. We get publicly available content so that people can test against it and figure out if this specification works for their engines. And yeah, this is kind of where I think the magic happens, is in stage 3. And then it gets voted for ratification, and stage 4 is where it becomes like super official, and this is an OMI extension, and it has a high potential for being something that is used outside of the OMI extensions. And these OMI extensions are just a vendor prefix that we rally behind, and we say we're going to follow that specification. And after it's been very clearly moving towards a wider usage than just in the OMI group, that's when it's considered for stage 5, which is the KHR prefix or extension. And this is a process that even I'm not extremely in, because I'm not part of like the working groups in Kronos, but I've been helping with the PR to get audio merged. And but this is the stage where things are kind of out of our control as OMI. We can only help answer questions and facilitate conversations that may influence changes, which we then push back to the OMI extensions, and it's kind of a bit of a juggling game to keep things in line. And that's actually the thing I've been struggling most with the audio is if something wants to be changed over in the KHR side, then we need to make sure that we're like mirroring the changes over. If we are going to have an OMI audio extension, or if we want to just do the KHR audio, which is what ultimately the group has decided, but that doesn't leave out the possibility of having other extensions if let's say the Kronos specification deviates from what people want to do in OMI. So it's standards are hard, so things are going to be like back and forth a lot, and a lot of people have different opinions on what should be standardized, and I'll get into some of those in just a moment. So let's talk about KHR audio. This background here is an example file that I have that has music embedded. So it's an album that I'm going to be putting out soon, where you just drop this file into a machine, and the machine collision with the file then says, okay, whatever audio is in the file that collided with it, play. And this KHR audio is an extension that's contained within that file and defines. There's binary data inside of it that has like the audio, or it could be a URL pointing to an audio file. And that's what tells it, okay, you're going to be emitting the sound into the world, but use a reference of the source of audio, and use a reference of the properties of the audio. Does it autoplay? Does it loop? That sort of stuff. So it started as the OMI audio emitter, and then it graduated up to the KHR audio extension, and it was very much inspired by the web audio API, the W3C standard. But also we were very influenced by the Microsoft audio emitter, and then most influenced, I think, from the Hubs component, the Moz extension for audio. That one was, I think, almost mirrored. I feel like it was pretty close to that one. And it's been implemented in 3.0v, though with some recent changes, I need to be updating the spec. So that's one of the hard parts of chasing specifications. You got to keep your code in line with it. So I need to push an update soon to make this work again, but currently it's in a broken state. Third Room also implemented it. I'm not too sure how, like, Third Room's an open source project, so I assume that anyone can pick it up and still build on it. So I highly recommend taking a look at it. And UX3D, there's a C++ implementation out there. That's kind of cool. So KHR Audio is composed of 3 different pieces of data. You've got audio and sources and emitters. And audio is the audio data objects where audio data is located. It can be binary data or it can just be a URI. The sources are what define the playing state for a given audio data. So this defines things like autoplay and all of that. I'll get into those in just a moment. The emitters are what actually use those sources that point to audio files to then emit sound in the world. And this can have many sources. So you can have multiple sources playing through a single emitter. So we'll dive into the audio property. So this is the data that defines where audio data is located. So this could either be a URI. You can see here this relative path of audio1.mp3 is the first audio in the list of audios available inside of this scene. Each audio item is reusable across sources. So you could say that audio 0 or audio 1 applies to source 1 and source 2 and source 3, and then you can assign them to many so that these are reusable and not tied to a node. So you're not redefining this data over and over again for every node that may have something like footstep sounds, or like maybe you hit something and it bonks. You want to be able to reuse those things as much as you can. So separating this out to an audio property does that. So the sources property, this is where we define things like the gain that's applied to the clip, if it autoplays, if it loops, and then audio, you'll notice has a number next to it. This points to the index of those many audio files or sources that are available in the document. So sources can be used as clips with behavior properties, and emitters can have multiple clips assigned to them, which allows you to do like layering and chained emitter logic across multiple clips. So in the emitters, this is the thing where we actually pull together the sources and start making it, I guess, perform in world. It can be either positional or global type. When you set positional, then that means you need to start setting positional properties like cone inner angle, cone outer angle, all of that other stuff. And then, as I said earlier, you can reference many of them. So in this case here, in this example, the sources are 0 and 1. So the index of 0 and the index of 1 of sources is what gets used inside of this emitter. Then in an engine like Three.js, you can say, okay, now create an audio source that's in this position. And notice, I'll show you in just a moment how position is established, because you'll notice here there's no XYZ of where this needs to happen. That'll make sense in just a moment. But we need to know how it's going to behave in that point wherever it exists. So the cone inner angle, outer angle, and gain, all of that is set up by this data object. And this mirrored the web audio API. Actually, this graphic to the left was almost a one-to-one copy of the audio API. So it's following established ways of handling logic of, audio being increased and decreased, and yeah. So this is what it looks like in an actual glTF file. We have on the left-hand side, you got scenes. And inside of the scene, there is, you can have global emitters. So like this, you can tie an emitter to the scene, or you can tie the emitter to a node, a specific object in the scene. So in the case of this scene here that has an audio emitter, it would probably just be 0, 0, 0 that you would deduce the object should be playing. And maybe that emitter is playing global audio, so the position doesn't matter at all. In the nodes, you'll see we've got a duck here, and this duck will play a sound. It's telling it to point to emitter 1, which would be the second item in the array of emitters. And it'll perform at the translation of 1, 2, 3. All of this, the positional, that you got the gain, you got the sources, all of those will respect the behavior. So the sources of 0 and 1, if the source of 0 is autoplay true, then that means that's going to autoplay. And maybe loop is true, it keeps looping. But for source 1, maybe that one only happens on a collision. And it'll respect those same properties of the distance and all that. So this shows that you can have emitters not on the global scale, like on the scene, and also on the object scale, like a duck. So what does this all enable? When files are actually using this, we can now use 3D files as a distribution format for audio. So that's why I'm building an album in this as a proof of concept of embedding audio within an object, which will be like an album, or I'm trying to make them look like data disks or something that's not standard in the real world, but just something imagined. And then I can distribute these, and then maybe it becomes like a data disk that other people use and reskin and make it CC0, so we can all rally behind something. So also the other benefit of doing this embedded audio is you can use a single file to distribute multiple things. Like you got a 3D object that has audio inside of it. If you were to do that today with like NFTs, you would probably have to make like an HTML page that has references to two different files. One is the 3D file and the other is the audio file. And that's not really bundled. That's not really hardened for the future. It's very fragile and could die as soon as the hosting is down for that app. So this gives you just a simple file where instead sites like OpenSea can just have a parser that knows exactly how to handle the audio embedded in the file, and then you're not having an app posted for a single NFT. And this can also be used in concert with other extensions to tie behaviors to audio playback. So OMI is working on a few physics extensions right now that could be used to collide and trigger audio to playback. So that's kind of how this starts to come together in a big open ecosystem of like glTF and behaviors and people making extensions. It's kind of, that's the open future that I'm aiming towards. And how do we take it further? So more extensions can be made for audio processing. That's, to me, very interesting. So you could say, you could take an emitter and then filter it. And maybe you have an extension for reverb, delay, or something else. You can then route the emitter into that and do those behaviors. And physics materials are also really interesting because physics can impact an emitter. So if your footsteps happen at the source of the character's feet, and you're walking on a metal surface, you might hear a metal kind of filter on the original audio of walking. And then maybe if you're on like muddier ground, it kind of squishes and plays another emitter of like the splashing sound on top of the walking sound. So I think that's also really interesting for this. And that's all I got to say about KHR Audio. I'll take a drink of my water. So any questions? And maybe if somebody can let me know questions from Discord if there are any. Yeah.
So my comment is Decentraland is updating their emotes to also include audio. Have you taken a look at that? Because I think for adoption, that could be a really good angle.
Yeah.
There's a whole marketplace, and it's very much like VR chat where emotes can be animations and audio.
Yeah, that's interesting because then you could totally do the animation with the stored audio. And oh yeah, and you can totally put the emitter like attached to the hand bone, like with a bone location or whatever, so that it like makes like a clap, for instance.
Yep. And
That's kind of been the
POVs.
approach that I want to take with adoption. With one of the ways that I was looking at KHR audio, or when it was only audio emitter, even I went to the Webiverse, the repo, and made an issue on pets having audio attached to them. So like your pet should maybe make a sound as it walks around, and maybe it has like a purr when it's happy or whatever. you could store all of that inside of a pet. And I'd originally made that an issue because I wanted Metaverse pets, I noticed, didn't make any noise as they walked. So you heard yourself walk, and then you saw the character catch up to you, and it was just like silent. And it was just kind of creepy even. But that was one of the areas of opportunity I saw for KHR Audio to be implemented, is like pets. It just makes a lot of sense. And I like the idea, because the thing that makes it shine is that audio is stored inside of a single object. So if that's the distribution method and everyone anticipates it, every single feature that's built on top of these platforms like Decentraland can utilize that. So clapping now becomes an event that's tied to an animation that's sold, by Decentraland, and maybe there's like other animations that can be your walking, but my shoes are, I'm wearing high heels, so I want to make sure that those have that sound. And people just start thinking about, okay, I can bundle audio. Audio is now essential to a 3D file. That's the thing that I think I want people to take away from KHR Audio. It's something that just should be part of a file, and we need to figure out ways to do it in a very compressed manner. Like MP3 files are pretty compressed, but we need guidelines on that as well, so that people that are making content aren't shoving gigantic files where it doesn't make sense. Like, you would put gigantic files for an album because you want it to be the best audio quality possible. But also, like, you also want to consider, is it positional audio? Are you doing things with audio flying around the character? The quality doesn't become as important because it can be only as good as, the rendering engine can process and deliver it. And it just, there's so many variables there. So, yeah.
Very insightful. Do we have any other questions for Ant?
So you had mentioned that Kronos are the guys that are the final arbiter because they're glTF on that. But do you think there's any interface with like MSF as the Metaverse Standards Forum, or
they're very, very much embedded together. They're working very close together on establishing these standards. So, like, I think MSF is working on something more official with Kronos, but I see MSF as the bridge for people to participate in Kronos if they don't have the ability to officially participate. And that's how I use OMI. Like, well, use OMI, but like that's why I participate in OMI. Is it's my way to be a part of the process, because all of the extensions eventually graduate to official extensions, or at least that's the goal for some. So that's where I feel like that's where we can make the most impact. And it's been cool seeing engines working together and platforms working together within these satellite groups that are happening outside of MSF and Kronos. And like, the reason I like those outside groups so much is because you can be far more scrappy than those groups, because they have so much process, and it's just hard to navigate people's schedules because they only work 9 to 5, and on the weekends they're not hanging out like we are on the weekends. So it's like the indie hacker space is where I've been trying to focus, and I feel that M3 and OMI is really the only two groups that I've found that have an actual path to becoming official influences in the future of the metaverse. And yeah, that's kind of where I see MSF and Kronos and all that.
No, thanks, man. That's really, this looks like great work. Do you think, now, I mean, could this be used, there's also a lot of audio as in voice. Do you think this has anything could you use this as a kind of a telephony product? I mean, it's
you
more
could
for
have.
kind of sound effects, but.
Well, yeah, it could actually have live audio as well. Like, the reason that we said that you could either point to binary data stored inside of it or a URI is so that URI could be an outside source. So that could be anything. You could point that to like a live feed of audio and bring that through to an emitter. But then that emitter, that extension, is not really for like an exchange format. Like, you're not trying to package that file with a reference to live audio to pass it to somebody. So at runtime, I think it makes less sense, but there's still a need. Like, if I were to have a performance that I'm giving on YouTube Live, and I wanted to pass out tickets ahead of time, and it was a 3D object that had a reference to the URL, that would make a lot of sense. So then I pass that to them, and that's live feed data. And then it's kind of interesting that the piece will die after that. Like, or well, I guess in the case of YouTube, they keep the VOD, but like the potential of a 3D object having a reference to a URL for content you can experience only one time, and then it just kind of fizzles out. It reminds me of Star Wars, where they have these like relics that show these holograms, and then they can only view it once and it self-destructs. And I think that's kind of an interesting way to use it.
Totally. Thanks.
Wonderful.
Cool. Well, thank you. I'm gonna jump off. Whee!